The scorching heat of August 1943 beats down mercilessly across New Guinea's vast expanse. High above, at 28,000 feet, Lieutenant Colonel Neil Kirby peers through his cockpit glass. His massive Republic P-47 Thunderbolt cuts through thin air like a steel blade. Below him spreads an endless carpet of emerald green. Coral atolls dot the azure waters like scattered pearls. Jungle-covered islands stretch toward the horizon. Each one has become a killing ground. Each one tells a story of blood and steel. But this day holds something different. Something extraordinary waits in the sky above Wewak. One American pilot in one enormous fighter plane is about to face impossible odds. 40 Japanese aircraft circle below like hungry sharks. Today will test everything Kirby has learned about air combat. Today will prove whether his massive Thunderbolt can survive what's coming. When Kirby's small flight of 4 Thunderbolts first spotted that enormous enemy formation, Japanese pilots felt a surge of confidence. Their confidence had solid foundation. Month after month, they had watched these new American fighters lumber across Pacific skies. The P-47s looked like flying barrels to their eyes. Bulky metal monsters that seemed to waddle through the air. Heavy and clumsy compared to their sleek Zeros. Awkward next to their nimble Nakajima Ki-43 Hayabusa fighters. The weight difference was staggering. American Thunderbolts weighed twice what their fighters did. The P-47 handled like a flying bathtub in their opinion. Some Japanese pilots radioed jokes to each other. Americans were flying beer kegs with wings attached. The laughter crackled across their radio frequencies, but that laughter would transform into something else entirely. Shock would replace amusement. Terror would follow shock. 850 caliber machine guns were about to unleash devastating firepower. A wall of lead would change Pacific air combat forever. This moment didn't happen by accident. Its origins trace back to drawing boards in Farmingdale, New York. Republic Aviation's offices buzzed with activity in those crucial months. A brilliant engineer named Alexander Kartveli worked day and night. He was designing something unprecedented, the largest single-engine fighter America had ever conceived, the heaviest fighter ever built by American hands. The year 1940 brought war clouds gathering across the world. European skies already screamed with combat. Sleek German Messerschmitt Bf-109s dominated Allied opposition. Fast Focke-Wulf 190s swept enemy fighters from the sky. America desperately needed something bigger, something more powerful than anything flying, something that could fight at altitudes where new bombers would operate. High-altitude combat demanded massive power. Kartveli's solution broke every conventional rule. Instead of building another lightweight agile fighter, he took a radical approach. He decided to wrap an entire airplane around one component, the most powerful engine available anywhere. The massive Pratt & Whitney R2800 Double Wasp became his starting point. This 18-cylinder radial engine was a mechanical monster. It produced an incredible 2,000 horsepower, but its size was enormous. Its weight was staggering. To harness all that raw power, Kartveli built an equally enormous airplane around it. The result defied every expectation. A fighter weighing over 7 tons when fully loaded, nearly twice as heavy as a British Spitfire. The Republic P-47 Thunderbolt earned its nickname quickly. Some called it the Jug, short for Juggernaut, according to some pilots, short for Milk Jug, according to others. Either way, it was a flying contradiction. Massive, yet surprisingly fast. Heavy, yet incredibly powerful. Seemingly clumsy, yet ultimately lethal. When first production models rolled off assembly lines in 1942, American pilots stared in disbelief. Nobody knew what to make of this mechanical giant. The first P-47s shipped to England in late 1942. They would serve with the 8th Air Force. The Great Daylight bombing campaign over Nazi-occupied Europe awaited them. British pilots accustomed to nimble Spitfires took one look and laughed. They joked that American pilots could defend themselves from Luftwaffe fighters easily. Just run around and hide inside the massive fuselage. American pilots weren't much more enthusiastic initially. When Ace Don Blakesley first saw the P-47, he made his opinion clear. It ought to dive well, since it certainly couldn't climb. But months of combat would reveal surprising truths. Both pilots and enemies would discover the Thunderbolt's real capabilities. At high altitude, above 25,000 feet, everything changed. The turbocharger gave the R-2800 engine maximum power output. The P-47 became surprisingly nimble in thin air. In a dive, it became absolutely devastating. That massive engine combined with sheer weight created incredible acceleration. Once a Thunderbolt pilot pushed his nose over and pointed earthward, physics took control. He could accelerate to speeds no German fighter could match. More importantly, the P-47 absorbed punishment that would destroy lighter aircraft. Its air-cooled radial engine had no vulnerable coolant system. German fighters couldn't puncture liquid lines that didn't exist. The massive airframe could take hits that would tear apart delicate opposition. One pilot, Captain Robert Johnson, proved this dramatically. German fighters riddled his Thunderbolt with over 200 hits. Any other fighter would have disintegrated completely. But Johnson's jug brought him home alive. Then there was the firepower aspect. 8 50 caliber Browning machine guns, 4 mounted in each wing, 3,400 rounds of ammunition ready to fire. When all 8 guns fired together, they created a devastating wall of lead. Any Japanese aircraft touched by this firepower would disintegrate instantly. Each gun fired at 800 rounds per minute. The bullets themselves were armor-piercing incendiaries. They burned at 3,000 degrees Fahrenheit, hot enough to melt aluminum on contact. By mid-1943, Thunderbolts were proving themselves over European skies. But the Pacific presented entirely different challenges. Vast distances between islands made range everything. Early P-47s simply couldn't fly far enough to reach targets. Agile Japanese fighters like Zeros and Oscars were built for maneuverability rather than strength. Most Pacific combat took place at lower altitudes. Altitudes where the P-47's massive engine couldn't develop full potential. Many Pacific theater commanders showed little interest in Thunderbolts. They preferred twin-engine P-38 Lightnings. Long-range and twin-engine reliability over water appealed to them. Some waited for new P-51 Mustangs with exceptional range capabilities. The P-47 seemed wrong for Pacific combat requirements, but General George Kenney, commanding the 5th Air Force in the Southwest Pacific, faced desperate fighter shortages. P-38s were in critically short supply. Tropical heat was creating maintenance nightmares for Lightning crews. Early P-51s hadn't impressed anyone yet. That left the P-47 as the only option available. Kenney was determined to make it work somehow. The first Thunderbolt unit reaching the Pacific was the 348th Fighter Group. Lieutenant Colonel Neil Kirby commanded this pioneering unit. Kirby was already a seasoned pilot when he arrived in Australia during mid-1943. Born in Texas in 1911, he had earned his wings in 1938. Over 5 years of flying experience prepared him for war. He was exactly the kind of aggressive, experienced leader needed. The kind who could make or break a new fighter's reputation in combat. When the 348th Fighter Group arrived in Australia with brand-new Thunderbolts, veteran Pacific pilots met them with deep skepticism. P-38 Lightning pilots looked at these massive single-engine fighters with particular suspicion. They had developed almost religious faith in their twin-engine aircraft. Having two engines provided invaluable security when flying over hundreds of miles of open ocean. If one engine failed in a P-38, the second engine could bring you home. If the single engine in a P-47 quit over water, you were swimming with sharks. General Kenny, aware of the serious morale problem, decided dramatic action was needed. He arranged a mock dogfight demonstration. Kirby and his P-47 would face Major Tommy Lynch. Lynch was the highest-scoring ace in the 5th Air Force at that time. He flew a P-38 Lightning with supreme confidence. Veteran Pacific pilots gathered to watch the demonstration. They expected to see the nimble Lightning make short work of the lumbering Thunderbolt. What they witnessed instead changed everything completely. Kirby understood his aircraft's strengths and limitations perfectly. He refused to get drawn into low-altitude turning fights. Those fights would give the P-38 every possible advantage. Instead, he used the P-47's superior diving speed brilliantly. He utilized its high-altitude performance to dictate combat terms completely. The mock battle ended with grudging respect from P-38 pilots. Thunderbolt crew morale received a significant boost from the demonstration. But mock combat was vastly different from real combat. Real combat against experienced Japanese pilots would test everything. Japanese pilots had years of combat experience behind them. Their aircraft were specifically designed for agile turning dogfights. This kind of combat had characterized Pacific air warfare since Pearl Harbor. Could a 7-ton fighter-bomber really hold its own against aircraft weighing half as much? Aircraft that could turn inside telephone booths? Kirby and his pilots were about to discover the answer. But first, they had to solve the critical range problem. The P-47D, as originally delivered, simply lacked sufficient fuel capacity. It couldn't reach most Japanese targets from Allied bases. General Kenny's engineering staff worked frantically on solutions. By late summer 1943, they had developed an answer. Massive 200-gallon drop tanks manufactured by Ford of Australia. These tanks were big and ugly additions, but they nearly doubled the P-47's combat radius capability. Now, Thunderbolts could reach Japanese bases previously untouchable by single-engine fighters. But reaching the enemy was only half the battle equation. The real test would come during actual combat encounters with Japanese fighters. Kirby and his pilots developed specific tactics designed to maximize P-47 strengths while minimizing weaknesses. They would climb to high altitude, often 28,000 feet or higher. They would approach their targets from above like hawks. Once over target areas, they would dive at tremendous speed, make their attack with devastating firepower, then use their diving speed to climb back to altitude before Japanese pilots could react effectively. These tactics weren't revolutionary or new concepts. German Bf-109 pilots had used them successfully over Britain during the Battle of Britain, but they were perfectly suited to P-47 characteristics. The Thunderbolt's massive engine provided superior power at high altitude. Its weight and aerodynamics made it incredibly fast in dives. Its rugged construction meant it could survive stresses of high-speed combat maneuvers, stresses that might tear apart lighter aircraft completely. September 4, 1943 marked a crucial milestone. Kirby scored his first 2 aerial victories using exactly these tactics. The system worked perfectly in real combat, but what happened on October 11th would make him a legend. It would send shockwaves through Japanese fighter squadrons across the entire Pacific theater. That fateful morning, Kirby led his flight of 4 P-47s on a fighter sweep. Their target was Wewak, a major Japanese base on New Guinea's north coast. Intelligence reports suggested heavy enemy activity in the area, but nobody expected what they actually discovered in the sky above Wewak. As Kirby's Thunderbolts approached Wewak at 28,000 feet, they spotted an incredible sight. Approximately 40 Japanese aircraft filled the sky before them. A massive formation of fighters and bombers spread across several thousand feet of airspace. Most fighter pilots facing 10-to-1 odds would have called for immediate help. Others would have looked for ways to avoid combat entirely. But Kirby saw a golden opportunity instead. The Japanese aircraft were flying at different altitudes. They were scattered across several thousand feet of airspace. His P-47s held the crucial altitude advantage. He knew that in a diving attack, they could build tremendous speed. Speed that lighter Japanese fighters couldn't possibly match. What happened next would be discussed in pilot-ready rooms across the Pacific for the rest of the war. Kirby led his tiny formation into the attack immediately. They dove at incredible speed into the mass of Japanese aircraft. Physics and firepower combined into devastating effectiveness. In just a few minutes of combat, Kirby personally shot down 6 enemy aircraft. This feat earned him the Medal of Honor instantly. It brought him recognition as one of the Pacific's top aces. But, more importantly for the bigger strategic picture, Japanese pilots who survived the encounter spread word throughout their air force. The big, clumsy-looking aircraft they had been laughing at for months had just torn through their formation. Like a buzz saw cutting through balsa wood. The .850 caliber machine guns arming each Thunderbolt proved absolutely devastating against lightly built Japanese fighters. Where a few hits from Japanese 20mm cannons might disable a P-47, even a short burst from Thunderbolt guns could completely destroy enemy aircraft. Japanese fighters touched by Thunderbolt firepower didn't just fall from the sky. They disintegrated in mid-air. The armor-piercing incendiary rounds could cut aircraft in half, often before pilots even realized they were being fired upon. Word of Kirby's incredible feat spread rapidly through Allied and Japanese air units. For Americans, it provided definitive proof that Thunderbolts could more than hold their own in Pacific combat. For Japanese pilots, it was a harsh wake-up call. They were facing a new and deadly threat in Pacific skies. But the real impact of P-47s in the Pacific went far beyond any single combat action or individual heroics. Between August and December 1943, the 348th Fighter Group claimed over 150 aerial victories. They lost only 8 pilots during this same period. These weren't just numbers on squadron scoreboards. Each victory represented a Japanese pilot who would never again threaten Allied bombers, never again support Japanese ground forces in combat. Each P-47 that returned home safely represented an experienced American pilot. A pilot who would live to fight another day, who would pass hard-won knowledge to newer pilots arriving in the theater. The psychological impact proved equally important to military success. Japanese pilots began developing healthy respect for the big American fighters. Radio intercepts revealed they had started calling them terrifying machines. They warned each other to avoid combat with the high-altitude monsters. The laughter had stopped completely. Respect and fear had replaced mockery. But Thunderbolt's success came with a heavy price attached. The same aggressive tactics that made Kirby so effective also made him increasingly vulnerable. Fighter pilots who became obsessed with running up victory totals often took dangerous risks. Kirby was no exception to this dangerous pattern. He had developed what some pilots called bong fever, a dangerous obsession with matching or exceeding the score of America's top ace, Major Dick Bong. On March 6, 1944, Kirby's aggressiveness finally caught up with him tragically. During a fighter sweep over Wewak, the same area where he had achieved his greatest triumph, Kirby violated one of the cardinal rules of Pacific air combat. After scoring his 22nd and final victory, he stayed at low altitude to confirm the kill, instead of immediately climbing back to safety, as doctrine demanded. 3 Japanese Ki-43 Hayabusa fighters caught him in exactly the kind of low-speed turning fight that favored their aircraft over his. The pilot who had taught so many others how to use P-47 advantages had momentarily forgotten his own crucial lessons. In the swirling dogfight that followed, Kirby's Thunderbolt was shot down. He was killed in action. But Kirby's death didn't diminish the lessons he had taught. It didn't reduce the impact he had made on Pacific air warfare. His tactics became standard operating procedure for P-47 units throughout the Pacific theater. His example proved that with the right approach, even the most unlikely aircraft could succeed, could perform roles it was never originally intended for. As 1944 progressed steadily, the Thunderbolt's role in the Pacific began evolving significantly. Capture of new island bases brought American forces closer to Japan itself, but it also brought new challenges and complications. Many captured airfields had short runways better suited to P-51 Mustangs than heavy P-47s. Additionally, the P-51's superior range made it the preferred choice for very long-distance missions. Missions that would eventually take the war directly to Japanese home islands. Many P-47 units in the Southwest Pacific transitioned to Mustangs during 1944. Even Kirby's old 348th Fighter Group eventually converted to P-51s in early 1945. But this didn't mean the Thunderbolt was finished in Pacific combat. Instead, it was about to find new life in a different theater of operations. The Central Pacific Campaign had been following a different path from the Southwest Pacific advance. While General MacArthur's forces island-hopped through New Guinea and the Netherlands East Indies, Admiral Nimitz's forces drove across the Central Pacific toward the Mariana Islands. This campaign required different tactics and different aircraft capabilities. The P-47 proved ideally suited for these new challenges. In June 1944, P-47s of the 318th Fighter Group participated in the invasion of Saipan in a most unusual way. They were launched from escort carriers just off the invasion beaches. This was the first time land-based P-47s had operated from aircraft carriers. It demonstrated the versatility of both aircraft and pilots who flew them. Once established on captured airfields in the Marianas, P-47s found themselves in an ideal role: ground support for ongoing infantry operations, strikes against heavily fortified Japanese positions. The Thunderbolt's ability to carry heavy bomb loads made it perfect for this work. Its ability to absorb damage from ground fire was equally valuable. The hot, humid climate of the Pacific also played to P-47 strengths. While liquid-cooled engines like those in P-51s could overheat in tropical conditions, the P-47's massive air-cooled radial engine actually seemed to thrive in the heat. Maintenance crews discovered that Thunderbolts required less servicing. They suffered fewer mechanical failures than other fighter types in the harsh Pacific environment. But perhaps the most important development for Pacific P-47s was still to come. Back at Republic Aviation's factories in Long Island and Indiana, engineers were working on a solution to the range problem that had always limited Thunderbolt effectiveness in the Pacific. They were designing a new version with longer wings, more fuel capacity than ever before, the ability to escort bombers all the way to Japan itself. The P-47 and Thunderbolt would represent the culmination of everything learned about Pacific air warfare. With its increased fuel capacity and refined systems, it would finally give American commanders what they needed: the long-range escort fighter required for the final assault on Japanese home islands. As 1944 drew to a close, and 1945 began, the Pacific War was entering its final, most desperate phase. The Japanese, pushed back across thousands of miles of ocean, were preparing for last-ditch defense of their homeland. They were training thousands of kamikaze pilots for suicide missions, building massive air armadas for what they knew would be the final battle. American bomber crews flying new B-29 Superfortresses from bases in the Marianas were beginning systematic destruction of Japanese industry and cities. But these massive bombers needed protection on their long flights to Japan. That protection would come from an unlikely source: the same heavy, barrel-shaped fighters that Japanese pilots had once laughed at and dismissed. The stage was set for the final act of the Pacific Air War. The P-47 Thunderbolt, now in its most advanced form, was about to play a starring role, about to help bring the war to a decisive close. July 7, 1945, brought scorching heat to Iwo Jima. Volcanic dust still swirls across the scarred landscape endlessly. Just months earlier, American Marines had fought one of the bloodiest battles in Pacific history on this hellish island. Mount Suribachi looms in the distance ominously. Its slopes still bear the scars of artillery bombardments and flamethrower attacks. But today, something remarkable is happening on this blood-soaked volcanic rock. The deep roar of massive engines echoes across the airfield. These powerful sounds announce the arrival of the most sophisticated P-47 Thunderbolt variant ever constructed. The 414th Fighter Group has just landed with their gleaming P-47N Thunderbolts. These machines bear little resemblance to the aircraft Neil Kirby piloted above New Guinea's jungle canopy. Engineers designed these fighters specifically for Pacific warfare. Extended wings stretch wider than previous models. Enormous fuel reservoirs dominate the design. Mission capabilities now exceed 2,000 miles without refueling. Single-engine fighters can finally escort heavy bombers on complete round trips. The journey from Iwo Jima to Japan and back becomes possible. First Lieutenant Urban Drew approaches his assigned P-47N. The serial number 448-8492 gleams on the fuselage. Detroit Miss 2 appears painted beneath the cockpit canopy. Drew already earned ace status shooting down German jets over European battlefields. This Pacific assignment presents entirely different challenges. European sorties lasted 2 to 3 hours maximum. These Japanese missions will demand 7 to 8 hours of continuous flight. Most flight time passes over empty ocean expanses. Mechanical failure over such distances means certain death. No rescue possibilities exist. Drew settles into the spacious cockpit interior. The seat remains among the most comfortable fighter designs of the entire war. This particular P-47N weighs nearly 20,000 pounds at takeoff. The weight makes it the heaviest single-engine fighter ever manufactured. That massive weight provides significant advantages. External fuel tanks allow the aircraft to carry over 100 to 200 gallons of aviation fuel. Combat radius exceeds even the famous long-range P-51 Mustang. The P-47's transformation from short-range interceptor to ultra-long-range escort fighter represents remarkable engineering achievement. Few aircraft underwent such dramatic mission evolution during wartime service. Republic aviation engineers completely redesigned the wing structure. Longer wings incorporated internal fuel storage within the wing roots. Each wing now contained 100 gallons of additional fuel. Total internal fuel capacity reached 570 gallons. This represented 200 gallons more than earlier P-47 variants. Fuel capacity formed only part of the engineering story. The P-47N featured sophisticated systems designed for pilot survival during grueling missions ahead. Advanced autopilot systems allowed pilots brief rest periods during long overwater segments. Enhanced heating systems prevented machine guns from freezing at high altitudes. Most importantly, reliability systems received major improvements. Flying 4 hours from the nearest friendly airfield made mechanical problems potentially fatal rather than merely inconvenient. Japanese intelligence services understood what was approaching their homeland. Reports warned about these new long-range American fighters arriving in the Pacific theater. Japanese air forces prepared defensive measures accordingly. The few experienced pilots remaining in Japanese service knew their lightweight fighters would be outmatched by heavily armed and armored American aircraft at high altitudes. They also understood that forcing Americans into low-altitude turning fights might give their more agile aircraft some advantage. Japanese commanders didn't fully appreciate how much American fighter tactics had evolved since the early Pacific War days. Combat lessons learned by pilots like Neil Kirby had been analyzed and refined through years of bitter fighting. American P-47 pilots now understood precisely how to exploit their aircraft's advantages while avoiding known limitations. The key involved altitude and energy management principles. The P-47N performed best above 25,000 feet elevation. At that height, the turbocharged engine developed maximum power output. Big fighters could dive on Japanese formations at tremendous velocities. They could complete their attacks and climb back to safety before enemy aircraft could react effectively. Japanese pilots attempting to follow Americans into high-speed dives discovered their lighter aircraft suffered from compressibility effects. The P-47N's robust construction handled these forces easily. July 13, 1945, marked the 414th Fighter Group's first strike mission against Chichijima. This heavily fortified island sat in the Bonin Chain. The mission achieved complete success. P-47s destroyed numerous ground installations while shooting down several Japanese fighters without suffering any losses. More significantly, the mission proved that very long-range fighter concepts could work operationally. American fighters had flown hundreds of miles from their base. They conducted combat operations successfully and returned safely home. The real test began when P-47Ns started escorting B-29 superfortresses on raids against the Japanese home islands. These missions pushed both aircrews and aircraft to absolute operational limits. Pilots took off from Iwo Jima in pre-dawn darkness. They climbed to altitude over the Pacific Ocean. Hours passed flying northward before even sighting the Japanese coastline. The most dangerous mission phase involved penetrating Japanese airspace while defending bombers from kamikaze attacks and conventional fighters. Psychological pressure on young American pilots was enormous. European missions offered options if things went wrong. Pilots could bail out over friendly territory. At worst, they might become prisoners of war. Pacific missions offered no such alternatives. Engine failure over the vast Pacific gave pilots perhaps 10 minutes to transmit distress calls before disappearing forever into blue emptiness. Many pilots carried extra survival equipment, knowing that water landings meant facing sharks and exposure. The slim hope of rescue by submarine or flying boat provided little comfort. Japanese defenders, meanwhile, were becoming increasingly desperate as the war situation deteriorated. By mid-1945, Japan's experienced pilots were mostly dead or severely wounded. Replacement pilots received perhaps 50 hours of flight training. Their American opponents logged 300 hours or more before entering combat. Desperation bred innovation, though. Japanese tactics began evolving in dangerous new directions. Unable to compete with American fighters in conventional air-to-air combat, the Japanese began using remaining fighters primarily to support kamikaze attacks. They positioned small numbers of conventional fighters to draw American escorts away from bomber formations. Meanwhile, waves of suicide aircraft approached from different directions. It was a cynical tactic that forced American fighter pilots to make difficult choices. When should they pursue fleeing enemies? When should they stay close to the bombers they were protecting? The P-47N proved ideally suited to this new combat environment. Heavy armament could destroy kamikaze aircraft before they reached bomber formations. Rugged construction allowed survival of explosion fragments when suicide planes were hit at close range. More than once, P-47 pilots found themselves flying through debris clouds from kamikazes they had just destroyed. Their aircraft's robust airframe protected them from damage that would have been fatal in lighter fighters. One of the most significant P-47N actions occurred in late May 1945. The 318th Fighter Group was tasked with conducting fighter sweeps over southern Japan. Their mission involved intercepting kamikaze aircraft before they could reach Allied shipping around Okinawa. May 25th and 28th saw P-47 pilots claim nearly 40 victories in these sweeps. They effectively decimated several Japanese kamikaze formations before they could reach their intended targets. These victories came at a crucial time in the Pacific War. The battle for Okinawa was reaching its climax. Kamikaze attacks were inflicting heavy casualties on the Allied fleet offshore. Every Japanese suicide plane shot down over Japan was one that couldn't attack American ships. Long-range P-47s provided vital early warning and interception capabilities that shorter-range fighters simply couldn't match. Perhaps the most remarkable aspect of P-47N operations was their reliability and survivability in harsh Pacific conditions. The aircraft's air-cooled engine proved virtually immune to tropical diseases that plagued liquid-cooled engines in the Pacific climate. Maintenance crews discovered that P-47s required less servicing time than other fighter types. This allowed higher sortie rates despite demanding operating conditions. The spacious cockpit, which critics had once dismissed as wasteful, proved to be a genuine advantage on ultra-long missions. P-47 pilots could stretch and adjust their position. They remained comfortable during flights lasting 8 hours or more. The aircraft's stable flight characteristics also reduced pilot fatigue. This allowed better performance during critical moments of air-to-air combat after hours of tedious overwater flying. Mexican pilots of the 201st Fighter Squadron demonstrated the aircraft's effectiveness in a different environment. Flying P-47s as part of the U.S. 5th Air Force in the Philippines, they completed 791 sorties against Japanese forces. They lost no pilots or aircraft to enemy action. This remarkable record spoke both to the P-47's durability and to the effectiveness of tactics developed around it. As 1945 progressed, American forces prepared for the invasion of Japan itself. P-47N units found themselves at the center of the most intensive air campaign in history. B-29s were burning Japanese cities to ash. They needed protection from hundreds of Japanese fighters that rose to meet them. P-47Ns provided that protection by engaging Japanese fighters at altitudes where American aircraft held decisive advantages. The technological gap between American and Japanese aircraft had become a chasm. Japanese fighters still relied on systems and tactics developed in the 1930s. The P-47N represented cutting-edge 1940s technology. Water injection systems gave the big radial engine emergency power boosts. These could add 800 horsepower when needed most. Sophisticated radio systems allowed coordinated attacks by multiple squadrons. Advanced gun sights and armor-piercing ammunition made every burst potentially lethal. Technology alone wasn't enough, though. The real advantage lay in the pilots themselves. By late 1945, American fighter pilots were the most experienced and best trained in the world. They had learned their trade in the crucible of 3.5 years of global warfare. They understood not just how to fly their aircraft, but how to fight with them effectively. Japanese pilots, by contrast, were increasingly inexperienced teenagers with minimal training. The few veterans remaining were flying worn-out aircraft with unreliable engines and limited ammunition. When these desperate defenders encountered P-47Ns over Japan, the results were predictable and tragic for the Japanese. First Lieutenant Ben Drew's mission on August 14, 1945, exemplified the final phase of P-47 operations in the Pacific Theater. Taking off from Iwo Jima before dawn, Drew and his squadron flew north toward Japan. None of them knew this would be the last full day of fighting in World War II. Their target was the industrial city of Nagoya, where intelligence reports suggested large numbers of Japanese aircraft were still operational. The flight to Japan had become routine by this point in the war. Hours passed, flying over empty ocean. Pilots checked instruments constantly. They monitored radio frequencies and scanned skies for other aircraft. As the P-47s approached the Japanese coast, though the mission took on deadly urgency. Radar stations were tracking their approach. Japanese fighters were scrambling to intercept the incoming Americans. The air battle that followed was brief but intense. Drew's squadron encountered Japanese fighters attempting to attack a formation of B-29s. The P-47s immediately engaged the enemy aircraft. American advantages in altitude, speed, and firepower quickly became apparent. Within minutes, several Japanese aircraft had been shot down. The P-47s suffered no losses in return. For Drew, who had survived aerial combat over both Europe and the Pacific, the engagement was notable mainly for how one-sided it had become. Japanese pilots were brave beyond question. They simply couldn't compete with experienced American pilots flying superior aircraft. The laughter that Japanese pilots had once directed at the flying barrels had long since been replaced by grim determination and barely suppressed fear. As the P-47s turned for home after the combat, none of the pilots knew that Emperor Hirohito was at that very moment recording his surrender announcement. The atomic bombs dropped on Hiroshima, and Nagasaki had finally convinced the Japanese government that further resistance was futile. The war that began with the attack on Pearl Harbor was ending. The P-47 Thunderbolt had played a crucial role in bringing it to a close. Statistics tell part of the story about P-47 effectiveness. P-47s flew over 746,000 combat sorties during World War II. This was more than any other American fighter type. They destroyed over 7,000 enemy aircraft, with more than half of those victories achieved in air-to-air combat. In the Pacific Theater specifically, P-47 pilots maintained a kill ratio better than 4-to-1. For every Thunderbolt lost in combat, at least 4 enemy aircraft were destroyed. Numbers alone cannot capture the full impact of the P-47 in Pacific operations. The aircraft succeeded not because it was the fastest or most agile fighter of the war. It succeeded because it was the most adaptable combat aircraft ever built. When the war demanded high-altitude interception, the P-47 excelled in that role. When missions required long-range escort engineers developed the P-47N to meet that need. When ground support became critical, the Thunderbolt proved devastatingly effective at that mission as well. The human cost of this success was significant, but remarkably low given the intensity of Pacific combat operations. The P-47's exceptional durability meant that pilots who might have been killed in lighter aircraft often survived to fight another day. Aircraft that would have been total losses in other fighters limped home with battle damage that seemed impossible to survive. Captain Francis Gabreski, one of the war's top P-47 aces, once observed something remarkable. When the Thunderbolt's 850 caliber machine guns hit an enemy aircraft, the target didn't just fall. It disintegrated completely. This devastating firepower became legendary among both American and Japanese pilots. Japanese survivors of encounters with P-47s spoke with genuine fear about the 8-gun devils that could tear apart their aircraft with a single burst. The psychological impact extended far beyond individual combat encounters. By 1945, the mere presence of P-47s over Japanese airspace was enough to disrupt enemy operations completely. Japanese pilots knew that engaging the big American fighters at high altitude was suicidal. They also knew that avoiding combat meant allowing American bombers to destroy their homeland unopposed. This psychological dominance represented perhaps the P-47's greatest contribution to victory in the Pacific theater. The aircraft had evolved from a questionable experiment into a war-winning weapon system. It could operate anywhere in any role, under any conditions imaginable. The same basic airframe that started the war as a short-range interceptor ended it as an ultra-long-range escort fighter. It could fly from Iwo Jima to Japan and back successfully. When the war finally ended on August 15, 1945, P-47 pilots like Ben Drew found themselves in a strange position. They had trained for years to fight an enemy that had just surrendered unconditionally. They had mastered aircraft and tactics designed for a conflict that was suddenly over. The vast Pacific, which had claimed so many of their friends and comrades, was now peaceful. Their legacy was secure, though. The P-47 Thunderbolt had proven that American industry could not only mass-produce military equipment effectively, it could continuously improve and adapt that equipment to meet changing battlefield conditions. From the factories of Republic Aviation to the airfields of Iwo Jima, the Thunderbolt represented the marriage of American industrial might with pilot skill and tactical innovation. Japanese pilots, who had initially laughed at these flying barrels, learned to respect and fear them completely. The aircraft that had seemed impossibly crude compared to their nimble Zeros and Oscars had proven that raw power properly applied could overcome agility and grace. The 850 caliber machine guns that had seemed like overkill in 1943 had proven their worth in thousands of combat encounters across the Pacific theater. The irony was not lost on surviving Japanese pilots after the war ended. They had spent years perfecting the art of aerial combat in lightweight, maneuverable fighters. They had been overwhelmed by opponents who succeeded through entirely different principles. The P-47's approach to air combat was simple: climb high, dive fast, hit hard, escape quickly. This represented a fundamentally different philosophy from the Japanese emphasis on individual skill and aircraft agility. In the end, the P-47 Thunderbolt's success in the Pacific came down to a simple truth. Wars are not won by the most graceful or elegant weapons available. They are won by the most effective ones. The Thunderbolt was never the prettiest fighter of World War II. It was never the most nimble aircraft. It was never the most beloved by pilots who preferred lighter, more responsive aircraft. But when missions required flying impossible distances over hostile territory, the P-47N had no equal. When the task involved engaging superior numbers of enemy fighters, it excelled. When the goal was bringing bomber crews home safely, there was no better aircraft in the world than the P-47N Thunderbolt. The massive radial engine that had once seemed like a liability became a tremendous asset. The heavy armament that critics had called excessive became the standard by which all other fighters were measured. The rugged construction that added weight and complexity saved countless lives when battle damage would have destroyed lesser aircraft. The laughter of Japanese pilots had died in the skies over New Guinea when Neil Kirby demonstrated what American determination and engineering could accomplish together. The mockery had turned to respect over time. Respect had turned to fear. Fear had finally turned to defeat as wave after wave of Thunderbolts hammered Japanese air power into complete extinction. As the last P-47N shut down its engines on Iwo Jima in August 1945, the pilot might have reflected on the remarkable journey. 4 years earlier, the Thunderbolt had been an untested experiment. Many dismissed it as too big, too heavy, and too crude for modern air combat. Now, it was the backbone of American air power in the Pacific theater. It had escorted bombers to every major target in Japan. It had swept Japanese fighters from the skies with methodical efficiency. The Pacific War had demanded everything from the men and machines that fought it. Vast distances challenged every aircraft design. The hostile environment tested human endurance. The fanatical enemy pushed both technology and courage to their limits. In this crucible, the P-47N Thunderbolt had proven itself worthy. Not through grace or elegance, but through simple virtues: reliability, durability, devastating effectiveness. The 850 caliber machine guns had indeed rained lead on those who had once laughed at them. In doing so, they had helped bring the most destructive war in human history to its conclusion. The age of the Thunderbolt was ending as jet aircraft began to emerge. Its legacy would endure, though, as a testament to American ingenuity, industrial might, and the courage of young men who flew these magnificent machines into battle over the endless blue expanses of the Pacific Ocean.